Let's get going. Before we get started, I'd like to do a quick survey around the room. How many people here have a production web application deployment in AWS right now? That's a lot of people. How many people have a WAF in that deployment as well? So that's not a lot of people. How about autoscaling? How many people here autoscale their environment with ELB? So that's a good number. I mean, it looks like about half of the room here. You guys autoscale using ELB primarily, or other tools? How many people here use ELB versus their own homegrown tools? Most people use ELB. Got it. So that's actually what we wanted to start with. We've been first of all, AlertLogic primarily works with cloud and hosting customers. So we have a lot of data about incident trends that we see. We have some people here in the room. Amanda's back there. She's got a copy of the cloud security report that we put out. Because we have a lot of live incident data, one of the viewpoints we have is the premise that everybody has, that the cloud is less secure than on-premise deployments, especially enterprise deployments. Is that really true or not? At least in our estimation, it doesn't appear to be true at all. In fact, we see higher attack frequency in enterprise deployments. I think a lot of it has to do with the fact of what's actually deployed in many cloud environments. When we deal with cloud customers, a lot of times what we see are not necessarily entire data centers being airlifted into Amazon. It's applications, and those applications are usually protected much better than they can be in an enterprise environment. They have a very specific set of security groups. They have a very specific set of settings. Most of the time it's automated, so as a result, it's easy to do deployments, it's easy to do patching. So we see very different trends between on-premise versus cloud attacks. We see fewer of them, and as a result, I do believe that a lot of cloud deployments, if not are inherently more secure, but certainly can be more secure than on-premise deployments. Now, what we do see as a commonality between on-premise and cloud deployments is that web attacks are surprisingly high attack vector. We see it as one of the top 3 attack vectors no matter where we go. So web attacks are fairly common. We're going to show you some other data that we have about what specifically we see in terms of web attacks. I think it's important to understand exactly not just is it a big vector, but also what are we being attacked with? Is it the most advanced attacks in the universe, or is it easy stuff that you should be able to filter out with fairly minimal effort, right? But in general, we see attacks be consistent pretty much across the board. We see it just as much in the enterprise as we see in the cloud. Attack frequency is smaller in the cloud, and also the exposed surface is much smaller. So as a result, we just see fewer incidents in most cloud environments. And those numbers might change as more infrastructure moves to the cloud, but so far, we haven't seen cloud environments be less secure yet. So what's interesting about security is when you talk to people that make decisions about what they want to buy in the cloud, security actually shows up at the very top of the list. But then when you talk to people about what do they actually have running in cloud environments, you find that there's actually not a lot of security tools. And is it because people don't care? It certainly doesn't seem like it's a low priority. And people put it at the top of the list in most major surveys. This is one done by the InfoPro group. That's a division of 451 Research. The way they do it is they call 400 to 500 mid-sized and large enterprises and ask them, how are you making cloud buying decisions? What's important to you? Security is universally cited as one of the most important things out there. Yet, again, when you talk to those customers about what do you actually do about it, there's not a whole lot out there. I think there's a reason for that. We'll get back to that a little bit later. But in terms of what attacks do you actually see out there, and what vulnerabilities do you see? This isn't actually our data. This is a company called White Hat Security. They do web application scanning, so they identify vulnerabilities out there. Their data actually correlates very closely to ours. This is the OWASP top 10 attacks, and the top 10 for OWASP has been stable for probably 2 to 3 years at this point, maybe even longer. These are very common web application attacks. These are things like cross-site scripting, information leakage, content spoofing, command injection attacks. This top 10 has been out there for a very long time. This is the bread and butter of most web application breaches. The reality of it is that a lot of web code out there is riddled with holes. It's relatively easy for somebody to find out what they are. I suspect at some point when the defenses get strong enough, we are going to see more sophistication out there. But that's not what we see today. That's not what White Hat sees either. So this is our data. In terms of which specific attacks that we see out there, what's fascinating is that Havage toolkit, which is, I mean, it's got a graphical UI, so you know it's not written for security experts. It's written for script kiddies, right? Is the most common tool that we see out there. Vast majority of the web attacks that we see are generated using a very simple to use toolkit. Anybody with marginal technical skills can find web application flaws, exploit them, and until we reverse that picture, until we make it more difficult, I suspect that's going to stay the same, or we're going to see the same picture, right? Now, just fundamentals of what web app firewalls do. By the way, in this room, how many of you feel like you have a fairly good grasp of what a WAF is and how it operates? So it's not everybody. I'm not going to spend a lot of time on this, but the basic idea is that you put an inline proxy in front of your web service. It's a reverse proxy. It essentially allows you to filter out malicious traffic. So the assumption is that the WAF can identify malicious attacks out there as they're traversing the network, and before they get to your servers, you can filter them out. So good, theoretically at least, good sessions continue forward. SQL injection, cross-site scripting, all the stuff you want to block gets blocked. This technology has been around for about 10 years. It's not new, so it should be fairly pervasive. And what makes WAFs work, really, right? There's really two types of them, and there's two major technologies and two major approaches that you find in the WAF world. One of them is reliant on blacklisting. The whole concept there is that you have a static rule set, very similar to antivirus, right? Static rules. You essentially define what a SQL injection attack looks like. That allows the WAF to match on a typical SQL injection attack and other attack types and filter that out. That's a very simple way to get value out of a WAF. It starts working as soon as you put it into production. It'll start filtering out. A bit more false positive prone. Obviously, these rules cannot be accurate 100% of the time. They don't always work, but it is the fastest way to get value out of a web application firewall. Now, most of the flaws out there, and we don't have a slide on this, but I do have one back at the office. Most of that exposed surface in web applications is actually custom code, right? It's code that some developer wrote. It's not commercial quality software. It's not really well-known flaws. It's just web code that somebody banged out, and there's unfortunately there's a SQL injection flaw in it, or one of the other flaws. So typical static rules can't find every single flaw out there. There's quite a few of them out there that are in custom code. For those type of flaws, whitelisting is a much better approach. What it essentially does is learn the application. So imagine your web application firewall sits in line, certain number of requests later it figures out, I sort of have a sense now for what your application looks like, what it should or shouldn't do. At that point, it starts to block and it starts to filter out malicious traffic. So the benefit of the whitelisting approach, it is slower. It takes time to figure that out. But once that happens, it is essentially now tuned to your specific application. So it's much more flexible. It's much more tuned to your environment. It's certainly much more accurate way to go forward. And in a lot of ways, if somebody's tuning the WAF properly, a lot of times they will then depreciate the blacklisting rules and then use more of the whitelisting rules because those are actually tuned to the specific application. So the problem with all this is that it's fairly complex and it doesn't let you autoscale easily. So before we get into that, just a couple of words on, this is not a web autoscaling session. There's probably a number of sessions at reInvent where you can learn about how to autoscale your web tier. We're going to talk about security first and foremost, but when you're talking about architecture, there's a couple of things that you have to have in place in order to autoscale easily, right? One of the most important is that ideally your application should be as loosely coupled as possible. The tiers that you're scaling should not be dependent heavily on each other. You should be able to scale them out linearly. Independent components talking to each other as little as possible through fairly well abstracted connections, right? So you want as little state as possible and as much an ability to scale these things out without having to scale in lockstep with all other layers, right? The second thing you're looking for is that you really should be designed for failure, right? So in addition to being able to scale horizontally, one of the #1 things you look for in autoscaling is you want fast bootstrap. When you autoscale, when you bring up a new instance to handle more web traffic, you want to be able to scale that rapidly. You don't want to have to sit there and wait for that instance to warm up and get into production over some time. So it's important to have fast bootstrap. That means that when you autoscale, it comes up really fast and it goes into production as soon as possible. And obviously, health and load conditions could be a precursor to an outage, but really an autoscaling world should be a trigger for autoscaling, right? This is what you're looking for in order to help you help your infrastructure know it is time to spin up new instances. It's time to scale. So the good news is, for web tiers, the web tier is by far the easiest to scale. If you talk to most people out there, you'll find that databases scale up more often than not. Web tiers scale out because they're easier to scale out, and they're a lot of times built using these principles in mind. Now, web application firewalls not as much. Web application firewalls are much more complex than that. And that's the reason why you saw so many people raise their hand when they talked about how many web production deployments they have. What did they do autoscaling? How few hands went up when they first of all even had a WAF, but second, had an autoscaling WAF. That's been very difficult to do because a lot of the architecture prevents you from doing so. But common toolkit for autoscaling. Again, we're not going to do a deep dive into this, but this is essentially tools of the trade if you autoscale your environment. Those of you in a room that already do this know this reasonably well. Elastic Load Balancer is a fantastic tool set for autoscaling, not just because it's a great load balancer, but because it has native constructs for how to monitor your infrastructure with CloudWatch, how to autoscale it, right? Health monitoring, in our deployment, we ended up using Amazon CloudWatch. It doesn't have to be the way you monitor infrastructure, but the integration with DLB makes it extremely easy. And Bootstrap, there's a whole lot of options there. You can do this pretty much anything you want. We're using a lot of CloudFormation. We also use a lot of Chef and Puppet internally. I would imagine that if you ask people in this room what they use, there's going to be a plurality of choices out there, and that's totally fine. There's no reason to get stuck on a particular configuration management toolkit. So why is it difficult to autoscale WAFs? First of all, couple of models that you'll see for WAF deployments. A lot of the traditional web application firewalls are appliances. It's either a hardware appliance or a virtual appliance. It's a proxy. You put it in line. Now, that appliance usually functions as an atomic unit, right? So if you put it in line and you want to do whitelisting, you're gonna have to let it sit there and warm up, learn about your application, then finally go into full protection mode and start blocking attacks. Great for security, fairly terrible for autoscaling. It breaks the principle of fast bootstrap. You can't easily autoscale something that has to sit there for as long as a couple of weeks. Zach, how long does it usually take to train a WAF on a moderately sized site? He's got a second delay or so.
There we go. All right, so it depends on the amount of traffic, but I mean, we usually do basically 10,000 request sample sizes for analysis. So, and that's per application, basically per URI, per path. So depending on how much traffic you have, that could take just a week to get most of your application covered. It could take a significant time, especially for parts of your application that aren't used very frequently.
So different vendors have different mechanics for how their learning engine works, but all of them require the WAF to see a certain amount of traffic before it can really decide that now I understand what all the paths look like, now I understand what all the parameters should be, and now I'm certain that anything beyond this should be blocked. Again, breaks autoscaling principles. That's probably one of the biggest reasons why you don't see a whole lot of WAFs in deployment, in production, autoscaling with the web tier, and that's a major problem. Web application threats are one of the biggest attack vectors out there, and we should be doing this stuff. It just hasn't been possible to do until we figure out how to re-architect this stuff. Now, the second flavor, the good news is that, first of all, these are CDNs. These are content delivery networks. Akamai is a good example. Akamai is probably the most well-known CDN out there. Akamai offers a WAF as an option, as an add-on to their CDN, but it doesn't do learning. It's a fairly static rule set, so it doesn't give you all the protection you're looking for. I think it's going to take care of the low-hanging fruit. it does give you, it doesn't autoscale, but essentially can handle as much traffic as you throw at it. So from that perspective, you don't have to worry about it. You simply redirect your traffic to the CDN, and you're fairly comfortable knowing that it's going to handle your load, but it's not going to be the best security model out there. If you have a fairly complex application, that's where CDN-based WAFs get less and less effective, right? So there's a lot of reasons why WAFs are difficult to autoscale. Native support and really architecture principles used in a lot of these products are just not compatible with autoscaling principles. So first of all, we're going to present the way we handle autoscaling for AWS. I think these principles really go for any WAF that you use out there. So if you have a WAF that kind of follows these set of architecture principles, chances are you should be able to autoscale it just as we did. The basic approach that we took was that we have to separate the control plane from the data processing plane. And if our WAF is one of the WAFs that does whitelisting and blacklisting, but what we try to do is make sure that when we learn about the application, we offload all of that information onto a master node. That master node really becomes the central point where all the configuration is stored. So when a worker, right, a worker for us is defined as an appliance that helps you filter out traffic. When a worker comes up, it doesn't have to sit there and go into learning mode. We've already learned what your application looks like. We already know what it should be configured as. There's really no difference between workers. Workers come up, they have the exactly same configuration as all the other workers sitting side by side with them. They should be able to go into production and Bootstrap as soon as possible. So by splitting the control plane and the data processing plane, it's allowed us to do that, right? And to get that done, we used a lot of the native Amazon technologies to build this. First of all, we use Elastic Load Balancer as a way to autoscale our WAF deployment. We use CloudWatch to help us monitor our WAF instances to know when we're going to autoscale them. We use CloudFormation extensively. This is actually a fairly complex deployment. Zach was just telling me a couple of days ago that if he was to do this by hand, or just to sit down and build one of these stacks just for testing, it would take him about a day to do it, and he knows what he's doing. CloudFormation, I think it takes, what, 15, 20 minutes max?
Not even now.
Yeah, actually, in the same room here on Tuesday, we had a boot camp, and we literally had 80 people in here spin off a sample WAF stack, including ELB, including all the NAT instances, including S3 and EBS, and all of it happened within about 15 minutes or so. None of it failed. Everything worked. That's the beauty of CloudFormation. CloudFormation lets you take very complex deployments that are very configuration heavy, automate them to the nth degree, and then get a stack that you can actually work from. Again, we're using S3 and EBS to make sure that we can share configuration data and log data between all of these worker instances. So now we have a way to kind of instrument all of our WAF operation using native Amazon technologies. We're no longer reliant on tight coupling between the master and the worker. At this point, they all work, they all communicate as little as possible and are fairly loosely coupled. So that's what allowed us to autoscale pretty dramatically. We primarily built this for VPC deployments. I think we could make it work outside of VPC, but I think it would be more difficult than not. And we've done this with quite a bit of traffic. We're gonna try to do it live, and we're gonna see how that goes. Now, we're gonna do a deeper dive into each one of these layers, but to introduce you and kind of orient you to what you're looking at. Let's see if I got a laser that works. So. If you use Elastic Load Balancer right now, this is the tier that you currently have in production, right? That's the internal Elastic Load Balancer that essentially fronts your web server instances. It is essentially what load balances between your web servers, right? And by the way, when you see WSM here, that is the WAF that I'm talking about. Our WAF is called Web Security Manager. So every time you see WSM on one of these slides, it is referring to WAF infrastructure. On this slide, and all the slides that come after it, you'll notice that the orange is Amazon infrastructure, the blue is Alert Logic infrastructure, and green is actually your infrastructure spun up on Amazon, right? So these are your instances spun up in AWS, right? So if you have a deployment right now and you use ELB, we essentially become an overlay on top of it. We have another ELB deployment that fronts our WAF units. That ELB deployment there's one group for the master, there's another group for the workers, and that lets us auto-scale our WAF tier independently of your web servers. We certainly don't want to scale, we certainly don't want to have a one-for-one relationship between the WAFs and the web servers. We have no idea what your application runs and how it auto-scales. That's not important. What's important is that when we get to the certain performance shelf with one of these workers, we can step up to the next level, spin up a new instance, and go into production. So we're going to get into more detail on this, but that's essentially what you'll be looking at over the next couple of slides, right? So at this point, we're going to do a live demo. Zach built a dashboard that lets us see that. So what we're going to do is, Zach, actually walk them through that. Can you tell them what we're autoscaling from and to?
Yeah, so this is actually just kind of a dashboard that we built when we were in-house kind of learning what autoscaling looks like. So we could kind of visualize it. We could take a look and see what was happening. But basically our top graph here is going to be requests per second and megabits per second of traffic. We've got the number of workers in the autoscaling group, CPU utilization. You see there, that's across the entire autoscaling group. That's also represented by the middle graph. Requests per second, megabits per second or gigabits per second, inbound and outbound traffic. And then in the bottom right corner, you see a graph of workers. You'll see that tailing down, that's actually, I went and ran this about an hour ago. That was actually the last time it auto-scaled back down because there was not load on it. And you'll see two lines there, a green line and a pink line. The pinkish line has unhealthy workers. And what you'll see is as they come up, they're not initially healthy. Means healthy to the elastic load balancer. So they haven't actually passed their health check and been put into the pool of workers that traffic's going to yet. But you'll see that the green line go up as the red line goes down, and you'll see little peaks as it scales. So what we're going to try to do today is we're going to try to go from a paltry, it was sitting idle, and we're going to go from 22,000 requests per second or so where we're at now to something around 350 to 400,000 requests per second. That'll push about a gigabit per second of inbound request traffic. So that is the actual, your HTTP headers, et cetera, that traffic. And that's what our WAF product's analyzing. It ends up being about 10 gigabits of traffic being served from the website in the back. You'll see the workers will scale from 2 to 32 is what I've kind of capped this group at. And this will take place over the course of the next 15 to 20 minutes. Basically starting off with a traffic generator. This is the I went viral. So what this does actually every 30 seconds is adds another 10% to traffic. Which is, my link is spreading and I'm getting hammered. So this is just one of the use cases examples we wanted to test when we were doing autoscaling.
And Zach, can you cover a little bit about traffic generation? I mean, obviously, in the real world, there's going to be a lot of diversity in requests, and certainly a lot of diversity in the amount of traffic coming out. But this is not necessarily a production environment. This is synthetic traffic, right?
Right. This is synthetic traffic. We don't actually have anyone that pushes this kind of traffic on a sustained basis. We've kind of overbuilt even for our existing customer base, and for most people, I think. If anybody here does a gigabit per second of inbound request traffic, I'd really like to talk to you after the session because it's really interesting to me. And we don't see that very much in real life with customers that we have now. So this is so we couldn't pull actual real traffic to play back given that we don't have that. So it is synthetic. Again, your mileage may vary. That's kind of true with anything that you're when you're sitting inline processing.
Another quick survey here, actually. How many people here have less than 100 megabits of web traffic today? How about less than 200 megabits? It's a lot of high traffic people here. How about less than 500 megabits? Less than a gigabit? All right. Less than 5 gigabits? Anybody have 10 gigabits of traffic or so, web traffic? Okay, so nobody has the top limit that we've hit so far, so that makes me feel pretty good about it. So again, we're going up from a very small deployment to just under 100 megabits. We're going to keep pushing this up. Now, we weren't able to get this dashboard to stay up the entire time, so we're going to flip back and forth between the presentation and this dashboard. We're going to see. So watch these graphs right here. Right, this is the traffic that you're really watching because that's traffic outbound. If you combine inbound and outbound, that's really the effective load that we're handling right now. So we're in a fairly small deployment right now, just a couple of worker nodes and just under a gigabit of traffic, and we're going to push it up higher and higher. All right. So in terms of the data flow, here's what's happening right now. And actually, at this point, this is exactly what this deployment looks like. I'm actually not sure how many web servers we have behind our internal ELB stack, but in the middle, right, are the ELB stack designed for the workers. We have a couple of worker instances there. That's really the minimum that we suggest, not because that's to handle traffic. We have workers that can handle anywhere from tens of megabits to hundreds of megabits. It's really for availability, right? You want to have at least a couple of them out there. That's what you want to autoscale from. So the data flow is such where a client sends a request. The request that traverses the first layer of the ELB stack, hits the WAFs. Malicious traffic gets filtered out, then it gets down to the internal ELB by the application, gets filled by your web servers, then flows directly out through the same stack. So everything flows through the reverse proxies in this case. Anything else to add here? Zach, you want to take this one?
Yeah, so there's a reason that there's two autoscaling groups, and we did have quite a few people in the room that use autoscaling, so I'm sure some of you use this trick already. We have our control plane where our master lives, and this is basically for management. It also does kind of collection of all the statistics and processes this information for learning and creating the whitelist rule set. That's an autoscaling group of one. We only need one to do those things, and we only ever need one, but we always want one. So what we've done, instead of just having a fixed instance there, we've actually still go ahead and we create a launch configuration, we create an autoscaling group, and we tell AWS there should always be one of these things. If there's an issue, if there's a failure, if you need to vertically scale your master, you can actually take it down, update your launch configuration with a larger instance size, and bring it back up, and it'll pick up where it was. So that it just buys you a lot of flexibility that way, and it buys you kind of some availability. Now, the control plane there, the master, actually doesn't have to be up for any traffic to be processed by the worker pools, right? So that's one of those things where you can take it down to upgrade it. If you have an issue, or you get a notification that your instance is going to be terminated because they're doing a hardware upgrade, for example, you happen to be on an old box, it's not an issue. The other autoscaling group, it's going to look pretty similar to what your web servers look like. It's spread across multiple availability zones behind an elastic load balancer. We use ELB health checking on it. There's actually a health check file that the appliances write themselves for the ELB to look for. They're fairly aggressive at shooting themselves in the head. So if they don't think that they're in a good place, they'll rip that file out. And then everything's handled automatically, right? The ELB will pull it out of the group, autoscaling will pull it out of the group, terminate that instance, stand up another one in its place.
Yeah, and this is an important note. If you go to our blog, you'll notice there's a blog post from today about kind of optimizing for cost. Obviously, autoscaling anything gets expensive if you stay in a top processing state. So we do have logic in there to scale it down as much as up, and that's really what Zach's talking about. You can modify it. So if you want to scale, if you want to give yourself kind of a soft rollback and you want to wait longer, there's certainly a way to do that. So to clarify something that Zach said, once again, traffic is flowing through the worker ELB group and the worker instances. Traffic is not flowing through the master, and that's the reason why there's only one of them. That master is only responsible for making sure that we can control the workers and making sure that the workers get their configuration directives, can persist logs, and so on. So if that worker dies, there's no issue. It will continue to operate. There shouldn't be a problem with flowing traffic. The traffic will continue to flow through the worker instances. We're actually going to use the same health checks in ELB to restart it and get it back into production. Right? Go ahead, Zach.
So yeah, auto-scaling parameters. So obviously these are defaults. They may vary for your application, and we want to kind of stay at pretty high utilization. You want to make the most of your money in Amazon. That's one of the things this allows you to do, is not have a lot of stuff sitting idle. So by default, we're looking at when you get above 80, we're going to want to scale up. We look at that if that's for 2 minutes, go ahead and do that. Scale down at 50%, and the scale down, we put a little bit of longer time on that. You know, once an instance up, you're paying for an hour for it anyway, right? So put a little bit of longer time there, give it a chance in case that was an initial spike, maybe before a bigger spike of traffic. In the templates that we use for most of our deployments, these are parameters actually in the template. So if y'all are familiar with CloudFormation, it is parameterized, and we can adjust those settings. Also, one thing to note, the autoscaling groups, the CloudWatch alarms that you set up for this, you own these. These are not ours. This is in your environment, in your VPC you control. So you can go and modify these. You've got an e-commerce site. You've got Black Friday coming up. You can go ahead and set an auto-scaling policy to just go ahead and ramp up 32 of these things on that Friday. You've got a Super Bowl commercial, ramp up 32 of them for your Super Bowl commercial. And you can do that along with default policy. We are using CPU as the default metric. Processing all the traffic is very CPU intensive. We don't really have any I/O issues there, but it is very CPU intensive to work processing that traffic on layer 7.
Configuration data flow, I'm going to let Zach cover the slide, but this is a little bit inside baseball. If you're into kind of web scale architecture, I think some of these things are interesting, but if you're using a WAF, I'm not sure if you really need to know about this. But Zach, you want to walk us through how configuration data flows? And honestly, if I was building another auto-scaling application, this is actually an interesting way to look at managing configuration and log data.
Right, so there's a couple of ways that we do this. Essentially, the configuration, like the control plane, that is on the WSM master. And we can do that from the outside through the Elastic Load Balancer. Obviously, this is security group controlled, so access to the management interface is fairly strict. What happens then with that information is it actually gets transported and stored in S3. We could have used something internal to the VPC to do that. S3 is very inexpensive, and it's also a little bit forward-looking to a solution that maybe works in more than one region. Right? S3 is just out there and available. Again, access to that's very controlled. We use IAM policies, again, automatically created for you. And those are your policies. You can manage them as long as we can have a role that those instances can talk to their specific bucket in S3 to do that. That configuration information is also transported back to us for backup and safekeeping in case anything were to happen. Basically what happens when a worker stands up, and I don't think that we have a slide that covers this, but the roles are driven by user data. So the user data that we'll create in the launch configurations has some information that they need to know. Workers need to know very little. They need to know that they're a worker, and then that they need to know that there's an S3 bucket that they have access to, and they have an IAM profile that allows them to access that bucket. They look for the things in that bucket that identifies where their master is, that identifies the configuration that they should start up with, meaning what websites they have, what policies they have, the blacklist and the whitelist stuff, and they can actually come up and process traffic. They can do that if the control plane is completely gone, as long as that information's been stored in S3. You just can't change the configuration without that master.
So I think this is actually a useful note for anybody that kind of re-architects applications for auto-scaling in Amazon. We started out with something that certainly wasn't designed to be auto-scaled with the LB, and the initial challenge was exactly that. It's way too tightly coupled. We have configuration data flowing back and forth between the master and the workers. We have log data that's flowing between the two. How do you pull them apart and allow yourself to auto-scale the things that matter, and then centralize all of the log and configuration data? I think there's a number of ways to stage that. You can use a number of, and not just these services in AWS. I think you can use a number of ways to share this data, but I thought that was a fairly elegant way of dealing with that. I think you'll find that you can do the same thing with kind of legacy web applications. If I had one and it was tightly coupled, that would be one of the avenues I'd look into for how to pull it apart, turn it from something very tightly coupled to something very loosely coupled. So we're going to flip back to our demo here. So Zach, what do we have now?
Let's take a look. So it looks like now we've kind of ramped up. We've got 8 WSM workers. You'll notice the CPU graph, right? This is I hit my limit, my alarm goes off, more workers are scaled up, and then my CPU usage drops. Same thing, again, I talked about before. You see the healthy and unhealthy workers. So we're approaching 100,000 requests per second, and we're just over 3 gigabits per second of outbound traffic right now. And we should see this continue to grow over the next 5 or 10 minutes, and hopefully we'll see the 10 gigabits outbound number.
Did we already cover this?
This is my slide?
Yeah, did we already cover this one?
No. So log and statistics collection. So there's there are a few interesting things that we want to know about the workers. One of the things we don't really care about is what it was. We don't want to know that there was 18 of them. What we really want to know is about the traffic that we're processing. So we do collect syslog from them, and they are identified as workers. We get some very little bit. We get some information about them so that we can do some debugging, troubleshooting, tracing if we need to. What we're really interested in is what they've done with the traffic. So statistics, obviously is very key. Deny logs, which is what we call our basically block event. You'll get a deny log message that has the request, has the reason why you blocked it, which policy it matched, et cetera, and access logs and other statistics. So how do we do that where we're not losing data? So one of the big things was, okay, the master can go away, so we do have to build some queues into these things. So not only do the workers have a queue that actually transports to the master has a queue for the things it can process. One of the things that is very interesting, especially about this demo here, is we're actually kind of hitting a burst capability in the master. We're using a relatively small instance size for the master. I say relatively, considering the number of workers that we have. So we actually hit a little bit of burst capacity, and we're actually kind of queuing some of this stuff that'll then filter out and take maybe 5 minutes or so actually to go ahead and process all that stuff, because it's a lot of traffic that we're kind of pushing through it for what it is. So what we do is actually the master runs just kind of a receiver that actually will queue in a EBS volume. This is an additional EBS volume, not the root EBS volume for the instance. It's unique to the stack, and that EBS volume is persistent across master instances. So what happens is if a master goes down, for example, it actually has a persistent queue on that EBS volume. The next instance that comes up as a master can actually pick up that queue and start processing that information again. So we're not losing data when that goes down, and we're able to kind of exceed capacity a little bit, and then come back and get in line and make sure that we're not losing that information.
So one of the most common questions we get is, this looks like fairly complex infrastructure. How do you insert this into my stack without breaking a whole lot of things and taking things out of production? So we've built a fairly easy way to put this into production. And what we recommend is that you don't just build an overlay on top of your existing ELB deployment and just go into production right away. What you want to do is build a stack. You want to give it some time. You want to pass some test traffic through it. How you do it is actually very much variable, right? A lot of it depends on what your infrastructure looks like. So there's a lot of flexibility there. You can redirect some portion of your traffic. You can redirect certain slice of your infrastructure. You can run test workloads behind it. So the very first thing you do is you stand up a sample WSM stack, right? And that's done using CloudFormation tools. We're gonna show you what those look like. That's gonna give you essentially kind of an initial deployment that you can play with. So again, it takes about 10 to 15 minutes. That will essentially create everything you need in order to be able to use the WAF with all the infrastructure in place, including all the S3 buckets and all of the EBS volumes. Everything will be stood up. At that point, you'll be able to hang servers under it. Now, once you're ready to balance to it, you can start redirecting traffic to it. So it's kind of a two-step process. Obviously, for more geographically diverse environments where there's a lot of complexity, it might be slightly different than that, but generically, it looks similar to that. Zach, anything to add here?
No. So there's a lot of ways to do this, and actually, one of the things we provide is we provide a couple of templates, and we'll show that before, but. There's some examples if you're not using CloudFormation to do stuff. It's nice to be able to show how you can integrate CloudFormation into your existing environment without necessarily even having to taking your whole environment and templatize it.
Just look back at the dashboard. Has it moved up a lot?
So it has. Actually, our numbers got smaller, but that's because we rolled from megabits to gigabits. So we're actually 350,000 requests per second. We're basically sitting at the limit of what the 32 could do, with just above 90% CPU usage. We're really utilizing all of those right now, and we're pushing basically 12 gigabits per second throughput, inbound and outbound traffic through those. And we'll see it now that it's hit that limit. We'll see that line kind of tail off. This traffic generator will actually stop after 30 minutes of it being started. We may. I don't think we'll have time to see it all scale back down, but we will see it stop and the traffic die. All right.
I'm glad this worked. I had nightmares of this failing.
Yeah, I've been to a few sessions and I've seen some other demos, and I know just showing the dashboard's not really showing everything that we can do, but the other demos that I saw were recordings. Well, we're actually doing this live in Amazon right now. That actually is, the 32 worker nodes, our master node, elastic load balancers. One thing, if you haven't pre-warmed your elastic load balancers, they don't out of the box do that kind of traffic. but they're fairly easy to pre-warm, or you can even, if you have support with Amazon, call them, let them know you're expecting increases in traffic. They can do that for you. That's actually using 220 nodes to push traffic through. Actually, just generating that much traffic was kind of difficult. I picked up off-the-shelf tools because I needed something to do quickly, but even just generating that much traffic isn't easy. That's auto-scaling group driven as well, and also CloudFormation. Like again, I said, this is a tool that we've used that's repeatable. We can use in-house.
Yeah. So a couple of words about sizing, because a lot of the decisions really deal with, do you really want to auto-scale with largest instances out there just because they give you the most load? Not always. You actually want to balance out kind of diversity and the number of nodes with the amount of traffic it can handle. Master sizing is not that interesting. These are inbound numbers, so with the smallest instance we handle, we can do about 250 megabits. Larger one can do 1 gigabit inbound. That's essentially what we were showing. Now with the worker instances, here's what I would not recommend. If you have a 300 megabit deployment and you're doing 300 megabit in and out, right? I would not recommend scaling with the C1 extra large instance, for example. That you probably want smaller instances because what you want is a good blend of number of instances you can flow through and amount of bandwidth you can handle. So the right number, the right instance for that would probably be C1 medium, right? Then the C1 extra large actually goes up to about 250 megabits, not 200, so it's slightly larger than that. Now, obviously, if you're scaling up to 5 gigabits or so, you obviously want to scale in with the largest instances that we offer, and you obviously want to choose the larger ones. So these are typical rules of thumb for how you want to do this. Anything else to add here? No,
again, and that's mainly cost considerations, right? You want to make sure that you're optimizing your utilization with your spend. One thing, for example, the demo I showed, we ended up at 32. That's just because that's the number I got to when I was testing stuff to see the 10 gigabit number. Theoretically, these are horizontally scalable, as many as you can put inside a subnet in your VPC. So if I could drive more traffic, I would test it to much higher levels just to see what I could do. But we've not had any issues going from 32 to 64 to even over 100 of these nodes.
Right. So to cover the deployment with CloudFormation, this is actually the parts that if you were trying to do this, and like I said, we had about 80 people doing this in the lab a couple of days ago. This is essentially what would happen when you run the CloudFormation templates. We stand up all of the infrastructure you see on these lists here. Zach, you want to go through that real quick? I don't know if we need a lot of detail on this, but
yeah. So basically, like I said, this is a VPC solution. So in the example and for the lab, what we did is we've got two templates. One stands up what looks like a basic auto-scaling environment. It's got an elastic load balancer. It crosses multiple availability zones. It's got public and private subnets. It's got NAT instances, so you can reach out from your private subnets to access things. And then what we do is obviously it creates route tables. It creates security group policies. A lot of that. There's probably about 40 or 50 individual things if you get down to this is an ingress rule, this is an egress rule, all the things that we do to create the stack. And then what we do is we have a second template that actually will take inputs from this, or it will take inputs from your environment. So it'll take your VPC ID, the subnet ID of your public subnets where your NAT instances live, the route tables that route the traffic to those, and actually then insert into the environment those things. It'll take the ELB name of your existing ELB, and so you could actually stand this up in your existing environment, route traffic through this on the side without actually affecting your existing traffic. You could use Route 53, for example, to send some subset of the traffic there, which might be good as a second phase after you've kind of stood stuff up to actually get that learning process kicked off in the WAF so we can get the positive rule sets generated, the whitelist rule sets. And so it's fairly painless deployment for how complicated the solution is. This is not something that you could do in a physical data center. This is not something that you can do in other virtual environments this easily. It's really amazing what we've been able to do with CloudFormation to kind of do this.
Yeah, so the CloudFormation process is actually fairly simple. Once Zach went through a whole lot of work making it work, but now that it works, it's actually very simple to get the templates and be able to stand up your own stack. You literally just load the template, you fill out a couple of addressing parameters. It asks you whether or not whether or not you have accurate information here, and off it goes. Same thing can be done with the command line. So if you're going all out, and for example, you're orchestrating your entire deployments using command line tools and using CloudFormation to stand up entire environments, you can easily use these CloudFormation templates as a starting point, and you certainly don't have to do it through the console if you don't want to. Anything else here?
Yeah, I mean, so we actually have one of our customers uses an in-house system they wrote that's kind of very much like Puppet. And it was something that they wrote a long time ago, back when they were doing this stuff in the physical world, and it's kind of migrated and migrated and migrated. And they've actually integrated being able to call these templates using APIs through their tool that are actually, well, they have API access already. They added CloudFormation API stuff to it, and we're able to do this and integrate it with their existing deployments. So now that they can repeatably stand up this as part of their web stack in their dev, their test, and their production environments.
Yeah, so whether you run it at the console, whether you run it at the command line, essentially the next thing you'll see is that your WSM stack is now ready to go. This essentially gives you a place where you can start playing with it and start testing it. If you would like to give it a shot, we'd love for you to try it, especially those of you that have a lot of traffic. We would love to check out what that looks like, because like Zach said, we've done it with fairly big deployments. We've done it in a lab with a lot of traffic, but in a lot of ways, real traffic is really where it's proven. So just because we can push 11 gigabits per second of synthetic traffic doesn't mean that that's exactly what we'll do in production as well. I think we'll get pretty high up there. I mean, when you're thinking about 32 different WAF instances, that's quite a bit of traffic you can process. That's more than I've seen in production before, but we would love to see it in very, very large scale environments soon. So that's all I have for you guys, and we do have copies of the cloud security report that I referenced earlier. Amanda and Patty are back there, so they have copies of those you can grab. We also have them available on our site. If you have people asking you about whether is the cloud really insecure, I think we have a lot of data points to disprove that notion. So I think we have some time here. So if any questions in the room?